We will continue our calculation now. We reached to the, after we identify or calculating the total flow and the slope of the pipe, we will work on the other parameters to calculate the velocity. As you know, we at the beginning of our calculation, we assume the calculation 1 meter per second. It is not, it's something just to continue on our calculation. But now I need to recheck again the velocity. How I can check the velocity? Now I have the total flow and I have the slope. I can use the other formulas like Manning or the other scientists. I will use this formula. I have the total Q, the total flow. I have the slope. I need to find this factor, key factor. How I can find it? It is like this. It will be the total flow divided on the slope. This is the total flow. I, from where I get this formula, this is the formula from the reference I used. This is the formula. K factor equal to total flow divided on the slope, and the slope under the SQRT, you can find it. Now I need to find other factor. Now I have the KW. I can use the manual way. There is some abacat, or we called it the diagrams. Let's start from, because I will start, let's say, with the diameter for the pipe with the diameter 200. This is the minimum diameter we are using in the sewage system or the drain system, 200. Let's search for the KW. We have the KW. Now what we have, it is 92. Back to the diagram, it is 92. It is between here, it is between 80 and 104, between these two two figures, between two numbers. And if you look here, you will see the percentage of flow within the pipe. It is the h, the height of the water divided on the diameter of the pipe. The height of the water within the pipe divided on diameter of the pipe. It will be like between 35 percentage to 40 percentage. So this pipe will be full by water. About this pipe will be 40% or less than 40% of the water will fill this pipe. And if you look here, I will find other factor. We called it the velocity factor, W, velocity factor. And you can see it is something, it is hard to work on these diagrams or these charts. And if you want each time to see KW and each time to back to this paragraph and take the H divided on D and W, it will be a long time. So there is other sheet designed to make our life easy. I will use it. It is this is the calculation for velocity in the pipe. Just I need to open this. Okay, this will start from the diameter 300. This is here you can find all the diameter. I will start from the 300, you see, until 2500. Here you can find the KW. In another way, in other meaning, all the data here, it just, we took all the data from this diagram and put it in the Excel sheet here for each diameter. You will see for the diameter 300, we found the K, we found the W, and we found the H divide H. H divide H, it is the percentage of fluid in the pipe. Now I just want to put here the K that I get from my calculation here. This is the K. I will just copy it. This is the kW. I will put it here. I will press calculation. Now what I have the percentage of water for 300. Now I have the diameter of the pipe is 300. I have the velocity factor. I will just copy the velocity factor here. I will put it here. This is the velocity factor. Now I need to check the velocity now. From how I can do that, I have the other formula. Now I have the slope of the pipe. I have the velocity factor W. I need to get V, the velocity. I will just put it here. It is this multiply slope. You see, it is 1.16. While what I supposed at the beginning, I supposed 1. So it's not correct. So what I will do, I will get the calculated velocity and copy it here. Again, you will see all the formulas changed. Now I can go back to flow here. You will see I will copy it again. This number it's increased a little bit. I will go again here, paste. You will see this is W again. I will take it again, put it here. You see it's almost the same, 1.16, 1.16. So it is just one round of repeat the calculation. I get the velocity. Now I need to continue also, because I get the velocity, I can get the H, the percentage of the fluid in the pipe as well. Here you see it is about, it's not that much, it is just 22%. For that the three and the diameter here, the diameter, this is for 300. And I'm sure if you go to the 200 it will be enough, 200, and it will be about 37 percentage. If you go back to the sheet or the diagram, choose the 200 and go. But why I put 300? Because I don't have calculated sheet for 200, because this sheet started from 300. Maybe I need time to re-input all 200, 250 also again, because maybe this is designed for concrete. This is sheet designed for concrete, if you notice, not for polyethylene. If you notice to the N, it is this is figure related to the concrete pipes. But anyway, this is the way. This is the method. This is the way that we are using to calculate the diameter of the pipe. Now I have the velocity. I have the percentage of the flow. I have the diameter, and I check the velocity, and it is okay. If I need to increase the velocity, maybe I can change the slope. If you see the slope 200%, it's a lot. Maybe I can make it less. But look to the velocity. It is still more than the minimum, because I have 0.3 is the minimum velocity, and maybe 7, maybe 6. But I will work on the concrete pipe. Let's say concrete pipe. Let's say 4. Then 4, so 0.3 meter per second it's the minimum velocity, and 4 per second is the maximum velocity. I'm still within the approved velocities, 0.36. But look what I gain from decreasing the slope. Decreasing the slope will decrease the excavation works, and that will affect the cost. But on the other hand, you cannot decrease the slope uh, as you want. No, there is a minimum height, for the above the pipe, for the crown of the pipe. Crown of the pipe, there is a minimum height for the sewage or sewer system, just to protect the pipe from the weather conditions, and to protect the pipe from the heavy loads maybe coming on the pipe. So we will say 1 meter or 1.5 meter above the crown of the pipe will be the